Hello, my name is Chameleon and I use Chameleon Office for project number 1. The building is based on the hexagons that are replicated on the facade, and there are in 3 layers of the structure frame, opening, and the glass frame. The glass frame is a stick to the facade, and the other 2 frames are located with an offset from the facade. So briefly, I would like to explain 2 other methods that I did not use, and then I will go to the method that I use. So if I wanted to put these hexagons on the facade, I had to kind of make a grid and then match all these centers of the hexagon in this sequence on every other point of this grid. And then draw the circles, and then after the circles, draw the hexagons. So I had to calculate the length and the width of the rectangle that passes through 2 centers of this hexagon. And through a very simple formula of Euclidean, um, the length and the width are actually shown in this picture. So the x is the square root of 3 divided by 2, and the other one is 3 by 2 multiplied by r. So the problem is that the Grasshopper cannot calculate the irrational numbers, or any calculator actually, the exact numbers. So the problem is that when it wants to calculate, the circles would not match, and if I want to draw the hexagons from them, I will have a gap between every other 2 hexagons. So that's why I did not use this method. Another method that I studied was the lunchbox. I kind of faced the same problem with a lunchbox, that I will not achieve to equal side hexagonal that I need. So with this lunchbox, I will have this plane, and the U and V, I again calculated it according to the proportion of the centers of hexagons in equal side hexagons, and the proportion of the length and height of the surface that want to match on. So with this proportion, I supported the U and V, and it seems that the hexagons are equal side, but when I draw the diagonals of the hexagon, I understood to create the triangle, I understood that they are not on the straight line. So I kind of have this wave, which shows that they do not pass from the same center, and they are not they pass from the same center, but they are not a straight line. So that's why I used a very simple method of hexagon cells. So in this hexagon cell, I created 3 by 3 hexagons, which is the minimum number of hexagon that I need, and I draw the triangles. I got the triangles from them, and then I got the centers from them in order to move, and also the scale. So the purpose of the project is to move and scale all these triangles at the same time with different numbers, values. So I use the method of attractor point, and it could assume like a light source. So each time this attractor point can change, and it changes the distances between all the centers of the triangles and the attractor point. So I give the remap number to the scale, so I will have different scales according to the distances, and I gave the reverse of this map to the move. So the result is that the smaller the distance is, the smaller the scale factor, and the bigger the movement in z direction. And then I offsetted them to create a geometry, and loft them, and then make the difference from them to get this model that I want to replicate on the facade. So this model actually, each time that I change the attractor, the openings, the scale of the opening, and also their direction in the z direction, z coordinate will change. And this will automatically have impact on the main project. So the next step is cut this model that could be replicated on a surface without any gap. So I had to cut this model with this bounding box that passes. Yes, this is the model. So I had to cut it with this bounding box that passes through the centers of the marginal hexagons. and then make the difference from them to get the model. So this is a model that can be replicated without any gap on the facade, and then I had to move it because it had some distance from the facade. I used the same strategy for the frame, the structural frame. So this is the frame, and then I added those structural bars that stick the frame to the facade, and got this cutted model, and again move it so it could be located with a distance from the facade. And I again used the same strategy for the glass frame. So the last step is to map and replicate all these models on the surface of my building. So the point is that in order to avoid the problem of edging, I had to use a continuous curve without any knots. So it doesn't matter if it's a square or L shape or whatever shape, it just needs to be filleted on the edge and to give a very continuous line on the plan. So then this building, the facade could be used as one surface, and it had to be divided through these surface boxes. And I used the same calculation, that is proportionate to the points of the bounding box of the primary hexagons and the length and the width of the building, and use it for the U and V value to create these proportionate boxes. And then I use the morph box to morph those panels to the facade. So this is the result of the main structure, the main frame, and then this is the result of the openings on the facade. So whenever I change the size of the hexagon, or the number of the hexagon in X and Y, and the shape of the whole building, and the openings regarding those in the slider, everything will change automatically based on each other. And this is the final result. So you see that it can also match on the L shape. So the last part is the congru part to see how I can implement a force onto these openings. So it's actually another method to use these openings. For this one, I use the triangles, the base triangles, and this time I use the very simple scale one. So all the scales are the same this time. And then I lofted them, then I used this mesh and the weaver bird to get the connections for the spring, and I use it for the first object, and I use again the unary force that I apply to all the nodes of the mesh of the hexagon, and the anchor points are the all of the points on the edges of the hexagon. So this is the result of the congru. And then I gave the gradient colors to see the stress analysis. I do have some problems in the third row, which I did not understand why, because I got all of them at the same time from the first hexagon. Thank you very much.